Today I'll be talking with you about the demographic transition model, probably the most significant and important model that we will be looking at this year. The demographic transition model is a way of looking at population and how it changes over time. So it's going to be really important to our understanding of not just population, but other issues like migration, like agriculture, like cities. We need to be able to understand this model very well. So please pay attention as I go through this today. Now, it's easy to think about the world's population as being this ever-increasing number, right? You can see from the chart here that the world's population since the 1960s has been growing at a very rapid rate, to the point that by the year 2100, it's going to reach about 10.9 billion, almost 11 billion people. But the world's population doesn't just grow at some consistent rate over time. It doesn't just go up constantly. There's variations throughout time and also in different countries. And so the population is growing, but it's not growing at just the same rate you always see on this chart. So it's really important to understand that there's a lot of variance across different regions of the world. Some places, as we've seen, have high birth rates, and some places have low birth rates. Some places have high death rates, some places have low death rates. Some places the natural increase rate, right, births minus deaths. Some places it's going up at a much higher rate than other areas. Right? So it's important to understand that it's not consistent across the globe. There's different levels in different parts of the world. And so countries are going through something called what is known as demographic transition. And it's a pattern of population change that is pretty consistent throughout history. And here is what the demographic transition model looks like. It's primarily made up of 4 phases of different levels of birth and death and population growth rates. On top of that, along with the demographic transition, there's another transition known as epidemiologic transition, which runs parallel to demographic transition and helps explain why so many of the changes in population are happening. They're very much connected. So as I'm talking about demographic transition and looking at each stage of demographic transition, I'm also going to be talking about the stage of epidemiological transition that it's going through. So here we go. So the first phase of demographic transition, known as phase 1 or the pre-industrial stage. If you're looking at this stage, what you're going to notice is that there's an exceptionally high birth rate, which is this red line in the graph. Birth rate is constantly going up and down due to natural changes of people having more babies or not having more babies. All right? And it's during this phase that you'll also notice that death rate is still relatively constant, but it's also very, very high, right? So we have a high birth rate that fluctuates, and we have a high death rate that's fluctuating as well. This is a period of time where, as you can see at the bottom, total population is staying relatively constant, right? It has small ups, maybe some small downs. Maybe it's growing, but it's growing very, very slowly, right? So during this phase, or as we call pre-industrial, this is a period where most people are farmers. They're having to grow their own food, what we call subsistence farming, and they're very much beholden to changes in climate, changes in weather that could affect their ability to grow their own food. This is a period of time during what we call the epidemiological transition, where famine happens frequently and people starve to death as a result of not getting enough food. Another impact on death rates during this time is there's a high level of diseases that wipe out massive numbers of people. So that leads to high death rates. You can see here that death rates will oftentimes cancel out any increases in birth rates over these periods of time. Okay, due to higher numbers of mouths to feed makes it harder to feed everybody, and therefore you have higher death rates. Okay, so you have a period of high famine high disease, right? Diseases that kill massive numbers of people, like, say, cholera or smallpox or malaria, polio. These are diseases that were very rampant pre-industrial periods, right? When most people are farmers. And each stage of demographic transition has kind of a general model of the population pyramid that goes with it. And for example, the Republic of Congo in 1980, right? You can see it has a very high number of babies, high birth, high fertility rate, but as you can see, big declines in terms of number of people going from 0 to 4 to 5 to 9. So you have a high infant mortality. And as you can see, the population pyramid is concaving in, right? It's kind of bowing inwards, all right? And so that suggests that people are not living very long, right? Low life expectancy. People are not living into their 50s very frequently, okay? Most people are dying by 50, 60 years old, right? And it's oftentimes because you have such a high infant mortality rate, right? And you have such poor access to food, or maybe disease is rampant, people are just not able to survive that. And the medicines are not available with which to survive that. All right. So in the modern day sense, there are no stage 1 countries left today. Even a country like Niger, which has a very high birth rate, very high fertility, all right, life expectancy is low, even they are not in stage 1 any longer. They have moved beyond stage 1 into our next stage, which we call stage 2, which is a transitional phase. Okay? During stage 2 of demographic transition, as you can see, the birth rate remains relatively high. All right, but what we notice is that you see a rapid decline in the death rate, right? And a lot of that is the result of a shift from being almost exclusively agriculture to start seeing the beginnings of a small industrial economy, which is what happened in the UK and the United States. These were the first countries that really moved into this stage 2 of demographic transition. The United States and the UK, they became much more industrialized. Less people were needed to work on farms. More people were needing to work in small manufacturing, okay? And so you started to see new techniques coming in, new technologies coming into farming, which produced new food sources, okay? And more people had more access to food. You also started to see an increase in medical technologies in these countries, so that diseases that might have killed people in the past, like, say, cholera, were now being dealt with through proper sanitation and introductions of new medicines and vaccines that might have helped with diseases. So you saw a massive decline in death rates, all right? But birth rates remained relatively stable. And so what do we see? During stage 2, you have a massive increase in total population. And the difference between the birth rate and the death rate, right, is the natural rate of increase. So all of this here in the middle is natural rate of increase, okay? And as I said, the reason we started to see this is you see famine becomes less of an issue. You started to see pandemics, which had killed millions of people throughout history, start to become less and less of an issue due to technology changes, right? And over time, countries like the US and UK became, much more stable in their population growth. And a population pyramid typically looks like a real pyramid, okay? You can see you're still having lots of births down at the bottom, but you can see that people are making it more through their younger ages, right? Infant mortality is far lower in a place like Cameroon. And you can see that the percentage of people making it into older ages is going up, right? Still at the top level, it's still pretty low, but it's getting better, okay? And you can see as they continue to transition, these bigger numbers will start to move up, and you'll see larger and larger numbers in the older populations, all right? So demographic transition stage 2 looks very much like a pyramid, as we see here. And here's just a couple other examples of that. You can see countries like Pakistan or Iraq, right? Countries outside of Africa do exist in stage 2, but predominantly most of the countries that are still in stage 2 are predominantly in those African countries in West Africa, Central Africa, Eastern Africa, where their populations are growing very, very rapidly. There's where you see the majority of stage 2 countries. Moving into stage 3. Okay, so you've had a stage 1, very slow growing or very stagnant economy, right? Pre-industrial phase. Now we're moving into that stage 2 where you have a stable birth rate, but a falling death rate, right? Massive population growth. Now we hit into stage 3, right? The birth rate starts to fall dramatically, right? You're now in a very industrialized economy. You have far more people leaving agriculture, moving to larger cities. Cities are becoming more urbanized, more areas becoming more urbanized. More people are starting to live in cities. That's where we're starting to see more factory, manufacturing jobs. You start to see the beginnings of more of a service-oriented economy. And we know if you're not working on a farm, you're living in cities, you need fewer children to be able to work on that farm, right? You have less space within cities, and so you see people having fewer and fewer children, right? Birth rates start to fall, and death rates continue to fall, right? City life, while it does have its problems, is still more safer than living in the country, all right? And so death rates start to fall, continue to fall, but they flatten out, right? Death rates start to flatten out. Due to changes in technology, greater medicine, people are starting to live longer, right? And so you see the population is still growing, but it's growing at a slower rate, right? Here you have massive population change. Now it's still growing, but at a slower rate, right? We still have an increase in natural increase, right? Natural increase is still happening, but it's happening at a slower rate. And as you approach the end of stage 3, right, natural rate of increase is very, very low. And this is great. People are living longer, but now during the stage of epidemiological transition, people are starting to die of old age diseases and also diseases that are created by man, essentially, right? So things like dementia, right, becomes more of an issue. Things like heart disease, cancers, those types of diseases become much more prevalent because, as we know, diets have started to change. They're living in more polluted environments. Conditions are better than they were when they were just a pre-industrial phase, right? But now because people are living longer, we're starting to see those changes in epidemiology, right? So people are dying of different things and they're dying at older ages. And so what does the pyramid look like? The pyramid looks like this. You start to see the rounding of the pyramid, right? No longer does it look like a true pyramid. It's starting to look almost like the tip of a pen, right? We have the point and it's kind of rounded at the bottom, right? You can see birth rates are stabilizing, right? There's very little difference between the youngest portions of the population, and as you move up, right, you have still pretty high numbers in the older generations, right? Those 40, 50, 60-year-olds. You're starting to see higher percentages of the population fitting into those areas, right? It's becoming much more consistent, all right? But this is a very typical stage 3, right? A little rounding of the pyramid at the middle and becoming more straight at the bottom, okay? So you can see a few countries here like Bolivia, Mexico, Haiti. These are countries all in stage 3 of demographic transition. All right, and now we get to the phase 4, right? What we call the post-industrial stage, or the stage of zero population growth, or ZPG, right? So we start out high birth rates, high death rates, but population growing very, very slowly. Then we have birth rates staying stable, but death rates falling rapidly, where we have massive population increase. Then we see birth rates beginning to fall, death rates still falling, but not as quickly. And so you have population growth slowing down, right? It's still growing, but slowing down until you reach stage 4, right? In stage 4, we again return to uneven birth rates, right? Birth rates will go up and down based on different circumstances, but relatively speaking, it's staying relatively constant. Death rates have remained pretty flat. Maybe they're still decreasing, but decreasing at very, very slow rate, right? So it almost appears flat, all right? So in this stage, population is going to what we call zero out, meaning that we've reached a state of equilibrium. As many people are dying as they are being born, right? And so you have the pyramid becoming much more stable, all right? And population will go up and down based on what happens with natural rate of increase, right? Some years you'll have more babies born than people will die, and some years you'll have fewer babies born than people dying, right? And so you have a situation where population is going to fluctuate very, very minimally during this stage, right? And what you see in terms of epidemiological transition during this stage is that those diseases that exist in greater quantities with older populations become even bigger parts of the death rates, right? So again, you're still going to see higher rates of heart disease, higher rates of cancers, dementia, right? But older age diseases will just continue to increase, being part of the problem in terms of death rates. All right, people will be experiencing them for longer periods of time, right? You may, say, for example, get cancer in your 60s, fight it off, and then it might return again in your 70s or 80s, right? Or you might, say, have cardiovascular diseases like heart disease that you might have with you for 20, 30, 40 years, right? You might start experiencing it in your 50s, and you'll continue to have it through your 70s, your 80s, your 90s potentially, right? So these are diseases that exist and are becoming much more prevalent in these post-industrial economies and post-industrial societies where they have zero population growth, is that people are living so much longer, right? Life expectancies are going up, that they're dying now of these diseases that old age brings on. All right, so a pyramid that you would likely see in a stage 4 is a pyramid that looks very much like this, right? You have it almost looks like a skyscraper, right? Where you have it's almost a perfect column, right? There's little variances here in different generations, but it's pretty stable, right? The bottom of the pyramid, right? The number of babies being born is pretty consistent, right? Pretty stable. As you move up the pyramid, it's pretty consistent, right? In terms of percentage of the population in each age group. All right, obviously until you get to the top, when in most societies there's very few people that make it into their late 90s and into the hundreds, right? So here's a pretty classic stage 4 population pyramid. Now, over the last few decades, right, there's been the idea that maybe there's an additional stage, stage 5, right, where population no longer is growing or maintaining its current level, but it's actually declining, where the death rate, because people are living so much longer, their life expectancies are so high, and because people are having fewer and fewer babies within these societies, that deaths overtake births and your population actually starts to decline naturally. And these types of pyramids look inverted, right? Where the bottom of the pyramid is becoming narrower and narrower and narrower, right? And you can see a country like Japan, where you can see over the last few decades, few generations, the number of babies being born has continually declined. So that their population is now the oldest population in the world, right? And they're very elderly. They have a very high elderly dependency ratio. You can see in a country like Greece, right, you're starting to see the effects of this taking place, right, where you're seeing fewer and fewer young people in the population, and so the population is getting older. A couple other examples, right? Italy, we saw this the other day, right? Its population has, its youth population has been shrinking for several decades, right? Germany has been experiencing this relatively in the last few years, right? Their number of young people being born has declined. It's remained stable over the last, say, decade, but before that it had been declining significantly, right? So Germany, Italy, Greece, Japan, their populations are actually expected to decline over the next few decades as a result of just having fewer and fewer children. All right, but you can see as we move through the different stages of demographic transition, right, you can see that we're going from areas of the world that are less developed, right, mostly African countries, to countries that are becoming more developed, right, in the middle, and then you have the highest levels of development are seeing their populations remain stagnant or in actuality declining. Now I'm going to have you kind of wrapping all this up. This model is going to be really, really important for us, okay? this model will really help us understand so many other things going on within the world and within individual countries. All right, and so we're going to come back to this very, very frequently. All right, and so it's going to be really, really important that we understand the demographic transition. And tomorrow when you come back to class, please have questions, and please be ready to discuss this more and look at this through the lens of some other things that we're going to be talking about, right? So it's really important that you understand this model, as we will be using it quite a bit throughout the year. All right, thank you for watching this, and I will see you tomorrow.